Hi there, in this video I'm going to go through the steps used to code the Euler method in Python. So here you can see I have a Jupyter notebook open and this is what I'm going to use to code. First thing we need to do is import a couple of libraries, and these libraries are NumPy. So I've imported NumPy and I've used the sort of abbreviation NP, which is fairly standard. And we're also going to use a library called matplotlib pyplot, which is to plot the solution when we eventually get it. And I've also used the abbreviation PLT for that. Okay, so the first thing I'm going to do is define a function. I'm going to call it Euler, and this function is, when presented with an initial value problem, is going to output the solution calculated using the Euler method. If you're unfamiliar with the Euler method, I suggest you check out the chapter 1 of the lecture notes. Okay, so and this Euler function has four inputs, f. Now this is the name of the ODE function, which we're going to define in a minute. T-span, this is a element of a two-array element, where the first element is the starting value of t and the second element is the end value of t. Y0 is the initial solution and h is the step length. Okay, so within this function, the first thing we need to do is actually calculate how many steps we're going to need. So this is the difference in the two elements of t-span divided by h. Okay, so you can see, so t-span -1 here, this is the last element of t-span, and t-span 0 is the first element. So find the difference between these, divided by h, and we're going to return the integer part because we want n steps to be a whole number integer. So next thing I'm going to do is I'm going to define two arrays, and I'm going to initialize these with all 0 values. And these arrays are t, which is the going to contain the t values, and also y. Okay, and y and t are n steps plus 1, so the number of steps plus the initial values. And we all know what the initial values are, because t0 will be the initial value of t-span, and y0 will be our y0, which is our initial conditions. Okay, so now what we're going to do is step through the Euler method for the number of steps. So I'm going to use a for loop here for n in range n steps. Okay, so this is a standard for loop, and the Euler method is a very simple method. So the nth plus 1 step is equal to the solution at the nth step plus the step length h multiplied by the function. And this is going to be a function of two variables, t and y, and we're going to enter in tn and yn here. Okay, so this advances the solution by 1 step. We also need to update our t value, which we simply add h to the nth value of t. And that's it. Okay, so that's the Euler method, so don't forget we need to return t and y. Okay, so this is the function to define the Euler method. So we now need to actually tell it to solve something, and I'm going to use the simple example from the notes. Okay, so we have another function. I've called it f. Okay, so this is going to contain our ODE, and our ODE is quite simple. It's just t multiplied by y. Okay, so we got the Euler method function, we got the ODE function. So now we need to set up the initial value problem. For this initial value problem, we're going to use a t-span going from 0 to 1. Okay, so our initial value of t is 0, and we're going to sort of advance the solution up until t is equal to 1. The initial solution is going to be 1, and we're going to use a step length of 0.2. Okay, so once we set up the initial value problem, we now need to solve it and solve IVP using the Euler method. And quite simply, we go ty, so these are the output from our Euler method function. It's equal to Euler, so this is what I called it here, and we got the four inputs. So f, this is our name of whatever I called this function here, t-span, the initial solution, and h. Okay, at this point what I'm going to do is I'm going to run the code just to see if it runs. Or whether it gives me any errors. Oh, yeah, it's giving me an error here. As you can see, I've got, for some reason, I've got one too many close brackets. So if we fix that, it's run. We haven't got, I mean, it's run, but it hasn't outputted any solutions. So the next step, what I'm going to do is just show you how we can create a table containing the solutions and also plot them. You don't always need to create a table of solutions, but sometimes it's good for some sort of some basic examples. And this table, it's going to be a pretty simple table. I'm going to output the values of t and output the values of y. So it's going to have two columns, t and y, and I'm just going to have a sort of horizontal line there. Okay, so if I run that, you can see I've got our headings. And what I'm going to do now is I'm going to loop through the values of t, and we're going to print using formatted print. We're going to print the values of t. So it's going to be the tn. I'm going to use two decimal places, and we're also going to print the values of y. I'm going to use 6 decimal places for this. Okay, so if I run that, and you can see we now have our table of t and y values. Okay, so t starts at 0, ends at 1, and here's the corresponding Euler method solution. Okay, it's also a good idea to plot the solution, especially if you've got sort of using a smaller step length, you've got many more values of t. So I'll just show you how to do that here. First thing we need to do is set up figure and axis objects. So to do that, we use fig, comma ax, plot subplots. Okay, so this sets up the figure and axis objects. And to plot, we simply use plt, which is the shorthand for matplotlib, and use the plot command. And we're going to plot t against y. I want it in a blue. I'm going to use a blue line with some markers, some circle markers, and I'm also going to give it a label. And I'll show you why in a minute. Okay, give the axis labels. So our x-axis is our horizontal axis is a t label. As you can see there, I've used LaTeX, and also for the vertical axis, which is the y axis, I'm just going to put y of t, or I could have just put y there. And finally, plot show, so we can display it. Okay, and you can see further down we have our plot. For some reason, just didn't finish the $sign in the vertical axis. So you can see we've got a plot of t against y, and that's our solution. Just now I did apply a label to the plot, and the reason I did that is because if we wanted a legend, it's quite simple then to add one. So you can see we've got the Euler method here. If I had other methods for solving the same problem, I could plot them on the same, and if I assign a label, we can then have a nice legend.